All right, hello everyone. Welcome to December's Eastern Canada virtual CNCF Meetup. Got a great talk today, and let's kick things off.
All right. Do I kick things off?
Oh no,
I've got it.
You did.
I've got it.
There we go.
Yeah, we got to go through a couple of housekeeping things, Ralph. We'll get to you.
Excellent.
All right, so I'm Jason Hattie. I'm one of your hosts for this meetup today. I'm joined by Michael Foster, and we will be your dynamic duo.
And if you're in Toronto next year when we go to in-person meetups, you'll probably see us out and about as well. We're based here.
All right, so a little bit of agenda today. I've got just the introductions for today, the housekeeping. We've got a couple announcements from the CNCF, plus, of course, a little bit of a launch recap for Cube 1.26. But of course, the meat of today will be the talk from Ralph, WebAssembly and Kubernetes, which I'm excited to hear. It's going to be great. And of course, we always wrap things up with a survey. Your input is always super useful for helping us plan these events and help them get better. So just to introduce today's speaker, just to give you a chance to fetch materials ahead of time. We're going to be early today. I want to introduce Ralph from Microsoft, Principal Product Manager there, and he's going to be giving a talk about WebAssembly and Kubernetes. But like Michael said, some housekeeping first.
So housekeeping, yes. So follow us and stay connected. I dropped a Slack link. If you haven't joined the Kubernetes Canada Slack community, I recommend doing that. On top of the event survey, we're going to be sending out some announcements in, probably the new year, early January, about what we have slated for next year in terms of in-person meetups, things that we're going to be doing virtual. So that would be your chance. If you want to recommend places to meet up as well, we're all ears. Would love to see you there. Of course, we have a Twitter, LinkedIn, and YouTube account where all of these will be posted after. And shout out to our sponsors, JFrog and Microsoft. You can also become a sponsor if you're looking to do talks or just join the community. We would love to have you. So a big shout out. They're the ones who make things run. So yes, and CFP. So like we said, we're doing in-person events. We would love if you're in Toronto, Montreal, Ottawa, Quebec, Waterloo, and you want to do a talk, especially in person, we'd love to have people out in the community who want to talk about their specific pet projects, especially if they're CNCF related. So you can follow that link to submit a talk. Yeah, we're aiming next year to have an in-person event once a quarter and a virtual event once every 2 months, or maybe like twice a quarter. It's all going to depend on basically your interaction with us and the talks that you want to put forward. And yes, keep an eye out for February events, Toronto, Montreal. We're aiming to do an in-person one in February. We might set a little, if you're in the Slack channel, a little poll to see what dates are working and when we can find a spot. But we look to give you a little bit more heads up because we know if you're in Toronto, Montreal, some people are working remote. It'd be really nice if you guys could commute to the place and come see everyone. And then event survey. So I know you posted this at the end, Jason. I moved it up because I wanted to make sure that people got this in. There's the link there. I'll post it in the chat as well. Really cool if you guys fill it out. I'll even chuck up some StackRox swag. So the open source StackRox project. A tumbler, a sweatshirt, some pens, and a notebook, and all that stuff. I'll do 3 giveaways at the end of this for people who fill out the event form. So thanks so much for your participation. I'm going to kick it off to Jason to talk about 1.26 release and some CNCF announcements.
Thanks, Michael. All right, so news from CNCF. Of course, Detroit wrapped up, but already on to the next one for next year. So CFPs, I think, just closed for KubeCon EU. I think they had a huge record for Amsterdam this year, but again, taking place April 17th to the 21st in Amsterdam for KubeCon EU. So you can already look forward to that. But they're not the only conferences in town. Of course, we have other conferences happening. I think this might be one of the first ones of the year. Cloud Native Security Con is happening February 1st to 2nd in Seattle. And so you can look for that. You can find the event on the Linux Foundation as usual. But I think they're already slated to be a great conference.
And I will be there. So if you're going, ping me. If you want to check it out virtually, let me know as well. I may have some extra passes.
Right on. Get the inside hookup. That's great. So just some news. This just dropped pretty recently. So your old registry friend kates.gcr.io is moving. They are changing it to registry.kates.io. So there's a blog post here that'll take you sort of what you need to know. But the TLDR is that container images for Kubernetes releases from 1.25 onward are no longer published to kates.gcr.io and only to the new place, registry.kates.io. So you might want to check out the blog post, see how it affects you, see what you need to do to make sure that your stuff stays up. And of course, exciting news as things progress through the year. We get some graduations. The GitOps duo are graduating. So Flux has officially graduated from CNCF. So now they've moved from incubating to graduate. So congratulations to Flux. That's a big move, and it's a lot of work to get there. And in no short, Argo has also done the same and graduated from incubating. And so it's really exciting to see the GitOps duo graduate. GitOps has just become a force to be reckoned with the community and the CNCF. And so there's just going to be more and more adoption of these tools, which is really, really exciting. And of course, Kubernetes never stops. 1.26 is out. The release notes are out. I don't think they've chosen a name yet. I couldn't find their special logo that they have for the release, so we just have to make do with the rocket ship. But 37 enhancements with in this release, with 11 going to stable, so a pretty big release. I think about right compared to, I think 41 was 1.25. And I've picked out a couple here. There's many more changes in 1.26, but you've got cross namespace snapshots, so you're no longer namespace bound if you're taking volume snapshots. We've got cAdvisor-less stats, basically. So we've used cAdvisor for many years, right, to get those stats from your containers, but now there's alternatives to that. There's a change in the credential providers. You may have seen this on GKE and other providers where they're telling you to authorize a little bit more differently, often with their own plugins. We've got service internal traffic policy now. You might be familiar with external traffic policy with your services. And so this is the same thing of being able to choose between cluster or local for node local routing. So useful in like daemon sets and things like that, and local workloads on the same node. And we've got changes in NUMA alignment in the topology manager. So if you're one of those places that are running HPC clusters or huge clusters that are doing huge workloads, this might be useful to you if you are specific about your CPU usage there. And even small changes like allowing stateful sets to control your replica ordinal numbering, in case you don't want to start from 0, you want to start from something else to help smooth out your rollout. That's all coming into 1.26. So releases are out. Check out the release notes. People have been doing great summaries. Sysdig has done their usual great summary as well. ArmorSec also has another one out there. So recommend you take a look, see what's there, see what might be exciting on the horizon for you if you're upgrading or close to upgrading to 1.26. And with that, I think that's the end of the CNCF announcements. And let's just get into the meat and potatoes here. I want to introduce Ralph again from Microsoft, Principal Product Manager, here to talk about WebAssembly and Kubernetes. So with it, Ralph, I will stop sharing and the floor is yours.
Okay. Can you hear me all okay?
You sound
Just
great.
make sure. Double checking. All right, good. A couple of things for those announcements are really, really cool. One is the Flux Advance. Jason mentioned the success of GitOps. It's really important to realize that the GitOps and traditional operations are sort of the flip side of what we do as engineers and operators and administrators. GitOps is not just a Flux thing. Flux enables the idea that you can pull, and by pulling, you can retain your own security credentials. Whereas in a push model, you have to give your security credentials to somebody else, which is fine when there's a few things, right? But as you want to add clusters, you have to continually push the credentials. And that becomes a sort of a collection of security issues there. So the fact that you can balance your choices depending on your scenario between the full GitOps pull model and a more traditional push model is something that's really important for everybody to appreciate, because you can make choices, and that's wonderful. So that's really important, I think, to see them graduate. The other one is the registry renaming. I think most people sort of get that they're supposed to, pull from a different location. One of the critical things is that this different location is federated in a different way, and the resources are shared. And so instead of being a horrible burden on the CNCF, financially, what we're doing is we're helping the CNCF become more sustainable and scale out better to all of us and our future selves, not just the selves that are here. And so it's actually really, really important to embrace that. So I'm glad to see that. It's a part of a good and healthy system. So with that, couple of comments. I'll start. So let me get this up and running. And when I get it up and running, then I'm going to come back here. And then I'm going to find the share screen button. And then I have to click something that says share my screen. And then you get magic inversion. Yeah, okay, great. And so then if I go to this, tell me if you can see the PowerPoint.
I see resources here and a link to the resources.
Okay, so this should look like the same thing, and I'm going to hide the the sharing thing for a moment. So if I've done this successfully, you're seeing the same thing that we just showed you a little while ago. And you can go to that AKAMS link for these kinds of resources. If you click the blog, I've got a whole list of various WebAssembly and Kubernetes with WebAssembly resources. So feel free to look at that. There's just a starting point for those links, and you can tag me on Twitter and things like this. That was the bottom one. So instead, I'll start with the top one. And then if I click go, you can see this is who I am. I'm product manager at Microsoft in Azure Core Upstream. Deus Labs is the organization that we run. I'm going to talk about the high order bits. So basically, this is WebAssembly and Kubernetes together. And the high order bits of the whole talk for people who are interested is why anyone even cares. That's the first one. It's the most important thing because not everybody will, and that's important, right? The second one is to sort of make sure we all understand, though, that Kubernetes is the JavaScript of control planes. I'll explain that, but you can probably guess it. And that WASM is going to be very, very important for our future clouds. It's not necessarily the thing you're going to start using right away. It's a thing you're going to think about for new opportunities with Kubernetes. You're going to use it only when you need it. And we're going to show you a bunch of demos, actually, 2 or 3 at least demos. I've got more depending on how much time we have here. And at the end, I'll give you some pointers. They're also in that blog post where you can try this stuff out on your favorite distro. It's easy to try on K3ds. I'll give you a link to our implementation on AKS, but you can try the same container shim all over. So why are we here? Well, it's obvious that I'm feeling no pain from Kubernetes, right? And nobody else is at all. Okay, there's some pain, but mostly it revolves around pain areas that we're starting to understand. So nobody likes YAML, except for it turns out to be useful. And there's a whole bunch of infrastructure work inside Kubernetes, things that sort of add stuff that we needed. Meshes, secrets, and you got to do security hardening, and then of course master various distros and the services they provide and so forth. But all after that, not small stuff, people are still building great things, and that's great. Why? And the answer is because Kubernetes is kind of the JavaScript of control planes. And by that, I actually mean both the good and the bad. And it's really important to embrace this. You may not like it, but you know it and you use it. I mean, maybe you would have built it some way differently, but it doesn't matter. Everybody is learning it. The tools are built for it. And so you get to join an ecosystem tooling and services that is very large and open. And that's very much the kind of JavaScript idea. It doesn't really matter whether it's perfect. It's about how much knowledge you can share and use. You can also take your skills all over. It's not just other people's knowledge, but your own that gets to move. So if you master Kubernetes here, then you can jump over to some other company and you get to sell your services there. And that's extremely useful for you. And it's also that you can take your knowledge and your apps all over. And of course, companies can do the same thing, which is great. They can think about looking to hire you. So what's the problem? Well, there is no problem if you think the current world of computing is intended to be the status quo. And it's a good world of computing, right? So the problem really is that the future cloud is already here. It's just unevenly distributed. The public cloud, things like Google Cloud and Amazon and Microsoft and DigitalOcean and all the clouds, Alibaba and OVH, no matter where you are, this epic has been fantastic, but it's stabilizing. And by that, we mean that the actual adoption curve has begun to slow. There's still a ton of work to be done. There's still a ton of money to be made, no matter where you are in the ecosystem. But it is beginning to bend toward flat. That'll take some time to finish off. But if you notice, it's interesting that chip production is not stabilizing, it's taking off. They're going up. It's been going up. Even during COVID, it's been going up. That makes it hard for you to find them, but that doesn't mean they're not being built. So the question is, where are they? They are at something I would normally call circumference or periphery compute. This is something the marketing engines call edge, and it's the wide array of computing environments that we still have and that we're building more of constantly all around the world that are not public hyperscale cloud, right? So what does this look like? I mean, if we scan back out and we think about where things were and what they happened and where we're going to go, the data centers were for industry, just very handy for all of us, right? DCs, data centers, and Kubernetes gave everybody cloud native operations, immutable, and 12-factor if you went all the way to grab all the factors. Most people don't, so it's okay if you haven't. But you also got DevOps, which is just a much more efficient way of delivering much more complex applications and fixing them when they go wrong. But circumference compute, right? CDNs, and you can think, I call them circumference because they essentially are this ring around the public hyperscale, is just getting to this movement now. So you perhaps have heard, or maybe you use Cloudflare workers or Computed Edge on Fastly, Netlify, Vercel, and several others. I think Akamai now has it as well. These are all based on WebAssembly, and they are a kind of PaaS or FaaS or cloud native experience. But the other compute on edge, not hyperscale, still doesn't have this cloud native and developer operation movement. And yet, industrial operations automation is growing 10% year over year to something like 400 billion by 2029. Now, all these data, these numbers I'm going to give you really quickly, these are all public numbers. It turns out that if you ask me what the Microsoft numbers say, they say something very similar. It's just that we pay people to get their guesses very, very precise so that they can be precisely wrong later. But roughly speaking, you can search for the figures that you're looking for and find something very similar to this. And it's not even that. Things like space onboard computing grows 12% to 2.3 billion by 2027. This is almost certainly a radical underestimate. These estimates took place before the war, and we now have seen that Starlink has provided a whole bunch of support to the Ukraine, and that has proved very, very useful, or seems to have been. And those kinds of events, despite the cause that we profoundly regret, those kinds of events drive the need for experimenting with computing, and that includes computing in space. There will be data centers in space by the end of this decade, which is amazing. IoT generally is approaching guesses of more than $1 trillion for the last 5 years of this decade. That's insane. That is larger than the original. When I saw numbers in 2018 and 2019 about what the cloud, IT spend would be for 2022, it was less than this. So the compute is already coming, but it's not hyperscale. And of course, you've seen this one periodically, more data created at the edge in the next 3 years than the last 30 years combined, with something like 55 billion or 60 billion devices generating 80 zettabytes of data by 2025. That's nuts. But what's really interesting here is you can imagine that no one is going to pay to ship all their data back to hyperscale compute. That data on that slide is not going back to hyperscale compute for processing only to then pay egress costs to come back out. Like, that's not going to happen. So what you can see, not only is the business opportunity very large, that means the market will be here because the opportunity is so great, but in addition, there are going to be other limiting factors like egress costs that force us to do the processing of data where the data is rather than move it around. That's important to remember. And almost none of this space is cloud native yet. Kubernetes is generally thought to not really be able to win here. But the problem is that the containers are likely the problem in that space for Kubernetes. Containers are not the best solution for most of this non-hyperscale and non-scale out computing. But Kubernetes could be. So the world we're looking at is smaller, much smaller, slower, because it doesn't have as much power, it doesn't consume as much power, and we're looking toward a world in which power becomes much more expensive as we transform our carbon-based, hopefully transform our carbon-based systems to generate electricity and consume them more efficiently, and also from non-carbon sources. We're going to be seeing slower compute, and it'll also be more heterogeneous. Operating systems will vary. Their real-time operating systems don't have containers or things like that. And architecture. So, we're like thinking about ARM and hyperscale, but there's going to be a risc-v coming along very quickly, and there'll be even smaller form factors and chips that come along afterwards. So the real question is, can we take the good stuff about Kubernetes productivity, the whole cloud native experience, the tooling, the ecosystem, and skills to this world? And the answer is yes, but one digression. It's important also to realize that you're coming to a Kubernetes talk, a meetup, and this is not a rant against containers. Containers remain 90% of the workload of scale out computing because they work great. They're fantastic, right? The first time I was able to use a container to start a database or something else that I didn't even know how to build. And I didn't have to read that giant README for all the environment variables and everything. I just worked, right? Made me realize that containers are fantastic, and they remain fantastic, right? But that means that we're going to have in the future, and again, we're talking about the future, if we want JavaScript of orchestrators power, we need those features that containers don't have. So let's talk about some of those. And we're going to need to use them together. Modules and containers will be essentially sets of features. You don't want to think about them as modules versus containers. Like, that's not going to happen. We'll talk a little bit about why it won't happen. But trust me, it's not going to happen. You're going to be able to use both. What we want to do is use Kubernetes. The feature set we need for small environments are super fast cold start. There's a reason CDN functions are WebAssembly, and WASM is a kind of a short version of WebAssembly, because we don't want to say WebAssembly too often because it makes it sound like we're chewing bubblegum. Super fast cold starts are a thing that containers don't do very well. Now, if you're thinking containers are fast compared to VHDs, the answer is, oh yeah, they are. But they're not very fast compared to native, but WebAssembly can really get going. I'll show you a couple of results of some demos where I can start WebAssembly functions in Kubernetes in not milliseconds, but low microseconds. And if I optimize them, I can get into nanosecond cold starts. And that's just nuts, right? And Kubernetes and containers don't get close to that. Not for any failure on their engineering parts at all. It's just that you're doing a lot more with a container than you are with a WebAssembly module. So the other feature that we get is by default secure. So WebAssembly denies access to the outside world from inside the module by default, and it's mathematically provable. That is, you can scan the module, right? And because it's a public specification and written in a form of assembly language according to the specification, you can actually calculate and define and find out whether it is trying to do something you don't want it to do. And at runtime, the runtime will enforce that anyway. So you can both verify ahead of time, and only the host can give it permission to do very specific things, which is the opposite of the container stance. The other thing, the feature that we were talking about, is that it's extremely small, which means, and by small, we mean on the order of 10 to 50 times less. I'll show you an example of this later, right? But when something's 2 megabytes and not 200 megabytes, egress, storage, and working set are all dramatically reduced. It is true that you might gain some features in a hyperscale there by being able to cut down your VMs, right? Or downsize your VM nodes. But that's probably not what most people are interested in. What most people are interested in is getting the same style of orchestration and compute to very different, smaller, non-scale out environments. And that's what we're looking for, and that's what small gives us. And finally, the portability in 4 dimensions. You have operating system portability, unlike containers, which have to be rebuilt for those things. You have architecture portability, unlike containers, which have to be rebuilt. You have language and runtime portability, using the system interface and WebAssembly component specifications that are being built. You'll be able to have runtimes support any WASI module and be able to link in any WASI component to your core component, for example. And then finally, location, because these things are small, because these things are immutable, you can move them around and bring the compute to the location you need to apply it to the data. And these are very important features, and containers don't really do these things as well as we might. And if you're doubting that, I'm going to do the inevitable, Docker thinks so too slide. They just released the Docker Wasm technical preview. In fact, they just today or yesterday released an upgrade that where they're calling the Wasm technical preview. They're calling it Wasm. The Wasm feature is beta, and that uses a container DSHM. And if you have questions about that, I'm going to talk about that more extensively. And here's Solomon, just to sort of hammer the point home. It makes perfect sense. OCI can package them all, and you should be able to build and run them all with Docker. And that's exactly right. So you're thinking of all of these things together. You're not thinking of them as exclusive one way or another. All right. So if I'm going to give you an example of what this looks, I need to give you an example. So I'm going to bounce out of here. This is the link blog right here. I want to bounce out of here and find the little demo node pool dance. So I'm going to bring this up. And I'm going to stop it for a brief moment. And I'm going to say, what we're doing here is we have a Kubernetes cluster with 2 different nodes, types of nodes by architecture. This is running in Azure. So this is Azure Kubernetes Service. But you can run this in any distribution. You can run in K3ds and so forth. The point here we're going to try and demonstrate is the architecture difference between containers and WebAssembly and how that works with Kubernetes. So here we go. First, you're going to say there's nothing here, but you'll notice that we have 2 node pools. We have a node pool WASI pool 1, which is an AMD 64 architecture, and a WASI pool 2, which is an ARM 64 architecture. And the ARM 64 architecture is about 30 to 50%, depending on your provider, 30 to 50% cheaper than the AMD. Now, right here, I'm going to stop the demo. What I've done is the Azure Hello is just a repackaged version of the Kubernetes, the classic Hello voting app that Kubernetes has had for years and years and years. It's a, I think it's a Redis or a Mongo container and has a little front end. And in this case, the containers have been accidentally scheduled to WASI pool 2. Now, I happen to know that WASI pool 2 is an ARM WASI pool 2. And so what you see is basic Kubernetes failure here, error image pull, because it's looking for the ARM architecture and not for the AMD architecture, right? So this should be a familiar failure case for all of us. And if you haven't done this yet, trust me, you're going to. So if we take a look at the WASI pool 2, right, which we did before, you'll see that it's WASI pool 2 is right there. And it is, in fact, an ARM 64. So the container, which is an Intel container, right, an AMD container, it needs to be compiled to that. So what we're going to do here is deploy, before we do it, we're going to deploy 5 different replicas of one application using fermion spin model, which is a fast function, and 5 replicas of the Deis Labs a slight model, which is also a fast function. But you can choose either app model or run WebAssembly system interface stuff directly. Now we'll get to all the details here, but if I apply it, right, it's going to go ahead and say, yep, great. And if we look at it, you can see that they get randomly scheduled, right? So right here, if you look down, the first 2 are still failing on ARM because they're Intel containers. And the others are randomly distributed, but they are the same WebAssembly application. There's been no difference here, right? And what I want to show you is that, in fact, to WebAssembly, the nodes don't make any difference at all. So I'm going to show you that by going ahead and jumping into the Intel, the AMD node pool. I'm going to delete the node pool, right? So this is pretty straightforward. I'm going to do it. I'm doing it in the portal to make sure everybody can see it. Now, right here, what you're going to see is not accelerated. This is how fast it happens, right? I'm going to watch what happens. So first, we're going to wait for the nodes to start being terminated, and there they go. And now that everything has been moved over, not by me, but by Kubernetes. If you look in the node column, you can see that everything has been moved to WASI Pool 2, and that is an ARM node set, right? And so this displays, one, how containers have issues when you want to move them around quickly. You'd have to rebuild that issue, that Azure Vote container set, and make sure it's multi-arch. And that means you've got 2 copies of the image, depending on what your node is. Whereas with WebAssembly, all I've done is terminated the nodes, and it just went and dropped my costs 30% because everything just moved to ARM. And I didn't do it, Kubernetes did it. So the idea here is to give you a strong idea of the portability and the kind of feature that provides you when you're able to do that. Okay, I'm trying to kill that. There we go. Thank you, Windows. Right? Now, to drive this home very quickly, there's a set of critical links in one slide. And if you want to, I'm going to skip through this a little bit, but I want you to understand that basically WebAssembly is a stack-based abstract VM spec. And it's been on all major browsers since 2018 for things like Google Earth, Adobe Lightroom, and many others. For example, all the browsers pretty much support it in some way. And in that model, as we said, the host controls WebAssembly modules by default. All the sandbox is still unbroken, though there are some areas where bugs have appeared and security vulnerabilities exist, and I'll describe where they are. But there are other things you got to remember. There's no threading, there's no GC, memory management, although they are on the way. And the second major part that I've discussed is the WASM system interface. Right, this is an abstract syscall spec for multi-language targeting and runtime interop that makes all the runtimes interchangeable and allows people to compete on features and optimizations rather than particular implementation of the syscalls. The other thing that is very important to understand is the WASM component model, which is tightly constrained interfaces that define capabilities. And so, we can go and talk about those. But just very, very quickly, those are the 3 things that are really important here in the WebAssembly space. So if you're interested in learning more about WebAssembly, it's those 3 things: the WebAssembly spec itself, the system interface, and the component model. If you want to, you can join and participate in the engineering of the Bytecode Allies, the Bytecode Alliance Foundation. And I have to obligatorily mention that I'm a board member at the Bytecode Alliance, representing Microsoft. So there's a good reason why I think it's a great place to be, and that's because I'm there. Finally, the sweet spots. So you've heard some of this, but I want to restate it very quickly. These are the only places right now where your engineering work could benefit dramatically from WebAssembly. And if you don't see yourself or your customers or your communities involved in these spaces, you probably don't have to think about WebAssembly right away. You probably don't. The first is fast processing and resolution. Fat, hefty hosts like a long-running web server that manages tons of thread pools, right? And tons of process pools. They're not the sweet spot for WebAssembly. There's a number of reasons. And if you ask me, I'll be glad to answer why there are. But they're basically details, but they're engineering details. The point is fast firing functions. Cold start 0 is one of the sweet spots. The other one is, regardless of speed, constrained and heterogeneous compute environments like raspberry-pis in a department store or a single node cluster underneath a desk in a tax firm might be actually your compute, and containers don't really play well there. There's not a big IT team, And pure speed is not really important. You really want the ability to project and move the computer around and have it just run no matter what the customer's IT environment is. And then WebAssembly is very, very good here. And then finally, OpEx and COGS reductions, depending on, this is going to be the only scenario that is important for hyperscale and others. That's when you can reduce the number of VMs in your cluster from 15 down to 3, right? And that makes a big difference in some cases. A lot of big companies in hyperscale just pay for sort of group lab style compute, and they share costs across divisions. You're not necessarily going to see the kind of cost reduction in those scenarios. But if you're a small company and you really want to bite your cents, your pennies, right, keep them close to the vest, you probably might be interested in this, even in hyperscale. So WebAssembly is already in Kubernetes. You may have heard of Envoy network filters and KubeWarden. That's already there. You may have heard that we built kubelet called Crustlet that was there last year. Our current approach is containerd shims. There's a modification of crun that works. Wasm Cloud uses CRDs. And there's some like older approaches like FASM, which is much more convoluted in deployment. So it's not like Kubernetes doesn't already have it inside it and already doesn't have an integration with it. It's that we need one that's fairly simple, right? And this is actually it, containerd run WASI shims. I can talk about containerd, but before I go into that kind of stuff, I really just want to make sure that you can go to containerd, install K3ds, bring up a cluster with a command and apply a deployment. And very soon you'll get cluster API templates for whatever distribution you would like to create and use WebAssembly from. Doesn't matter where. And we've got that. The link for the get start on both AKS and K3ds is in the blog post that I mentioned. So we talked about functions. I want to talk about pure speed. All right. And I'm not going to show you this because it's easier to just show you the results. But you can do this yourself with the quick start, right? This is using the quick start. This is from Fermyon. It's a spin app, and it's just a hello world function. And I want to point out that it's localhost. So one of the things you're not counting here is any kind of network transition or DNS work, right? So if you get that out of the way, you can see that, in fact, these functions are fast. We're talking 2 microseconds there. And this is unoptimized. If we worked really hard on optimizing it, we could probably get that under a microsecond into nanoseconds. That's crazy fast cold start time for an inbound function. And containers don't really do this. And you can do the same thing with in Azure, but you'll be able to do this in anywhere by adding the container shim for your distribution. But in Azure, we have a WASI node pools preview, so you can try that. The link's there. It's also in the thing. You can use both the Spider Lightning model or the Fermyon spin functions. You can just get started. It's pretty easy. This was just recently. Fermyon recently did their spin service, which works in AKS and in Azure Edge previews as well, because the same function in WebAssembly, so the same function works in their cloud service. It works standalone. It works in Kubernetes. So this also runs fine on K3ds and the whole thing. So if we change gears and we say slight, we're going to add services, right? Because you don't really usually do general processing. You're going to add a key value function in K3ds. And if we do that, here's what we end up with. So you can see this is a slight application, but what it's going to do is make a call to a file system, basically, and write values, keys and values. And in this case, we're actually touching the disk. So because we're touching the disk, it's only 7 microseconds. We lost 5 microseconds per request there on the fastest one. I'm kind of bitter about that, but let's face it, we're actually making an operating system file call there. You can see that the speed is really amazing. And the size is very, very small for these functions, well under a megabyte. So the last demo I want to show you, and I'll pop up here, make sure everybody's doing okay. Are we, did we just see 2 terminals? That was 11 minutes ago. Everybody okay so far? So good? We're about ready to wrap this up. Doing great is all I needed to keep going. All right. So the last demo is a little bit more complex because it's more real world. Okay. And this is a large, it's called Red Dog code. It's a 8 service. It involves Dapper. And this is essentially the architecture for this service. And you can imagine this is one of the more professional applications that Microsoft customer people have built in order to work through with their customers. You can see it's got accounting services, loyalty service, or May client service, virtual workers, and a receipt generation service down there. And we're going to focus on that one. So if we're doing things like this one, if we refresh them, you can see that that's the UI. And we got a dashboard and it shows everything going on and the whole thing. People down there in the order queue are buying methimazole and clonazepam and so forth. I don't know what they're buying. I never looked at that before. But just to give you an idea, if we go ahead and grab the kube config for this cluster, and if we then go and look at it, you can see that we've got a whole bunch of things going on in the service. So I want to make sure that this goes faster. Yeah, they're looking at the service now, added that service, and they're going to go ahead and get deployments. And you can see that this has been up and running for quite some time. And if we go ahead and look at the logs, you'll see that what we're doing is we're pushing messages back and forth to Azure Service Bus, which is a queue, right? And so there's some logging going on. You can see that this is all like there's some various serial log ASP.NET Core. So we're doing ASP.NET work. And if we do the logs for the actual receipt generation service, you can see that we're going ahead and stashing values there. And these are blobs in Azure Blob Store. You can see they're being there are receipts that are being generated. So these are JSON versions that'll be converted to images when you print them and things like this. So that's not a big deal. It's all a big service, and we're basically just showing you that. And if we go ahead and delete this, and I think we mistyped, yeah, I mistyped deletion. So I'm going to go ahead and show you the service, and this is actually, in fact, I'm going to stop right here. What we're going to do is we're going to actually delete the container that is for receipt generation, and we're going to replace it with the same service using a slight service. And you can see that we've got the key ID and the key secret for communicating with Azure there, right? But this is a WebAssembly implementation of the service. And so you can see that all we're doing is making one change. In addition to the image, we're specifying the runtime class. That's it. The image changed. The only difference to the YAML is that we're specifying a runtime class name, which describes to Kubernetes which containerd shim to use to run the image. That's the difference, right? And so we go forward, I think. Yes, we do. We've deleted that service, and we're going to actually go ahead and apply the receipt generation service in the receipt generation service for Slight. And we go ahead and create that. And when we go ahead and get the pods, we can see that it's already running right there. 5 seconds. It's in the middle of receipt generation service Slight. Remember our earlier demo, it doesn't matter which node this is running on now. You don't care. And that's a really cool thing. But if we go to refresh this, we can see that we're just getting a whole bunch more blobs, right? Yay, more blobs. They're all happening. So the service, the entire application is up and running. And now I'm going to show you the last thing. And this is another way of showing you the difference between a WebAssembly and a container. Now, I'm going to stop this and get that out of the way. If you see the, let's see, the second to the last one that says Red Dog Retail Demo, Red Dog Retail Receipt Generation Service, 5 months ago, it says 210 megabytes. That's pretty standard for a small .NET Core, ASP.NET kind of container. But the top one, Awkward Industries, is the same service in WebAssembly. It is 2.94 megabytes. And that is not the difference you're going to always expect. But a couple things should be clear. One is that you're not going to get 100x difference every time. And two is that you can run WebAssemblies and containers together on the same nodes. Containers have to pay attention and the WebAssemblies don't. So you can run them together. It's no problem. So this isn't an either or. You can go ahead and have some key WebAssemblies. So I wanted to give you a chance to do this. This is where we're going, right? The actual shim that we use is in Deus Labs Containerd WASM shims. And there are quick start deployments that you can try here. All of this stuff is available on the slide. So I'll go ahead and put it up here. So if you do the AKS MS Canada CNCF, you'll get this whole list here, and you can click on Ralph's top resources. Or if you want, you can just go here and go straight to that, and you'll get this whole lovely experience all over again. And I'm going to stop sharing, and I'm going to come back and say that in theory, oh great, Sven's here. The Quasm thing will show you how to use the same exact shim on all of these other things. GCP, DigitalOcean, probably EKS. You have one, Sven. If you don't have one on EKS, then you're dilatory and very slow, and you should get to it. So let's have some questions. I hope this was interesting, but it is a lot of information. The high order bits are give it a try. Remember that it's not perfect and not production yet, and focus on the environment that could take a benefit from this and not on some idea that we're all supposed to move to something else. That is not true. All right. I hope that was interesting.
That was interesting. I was captivated the whole time. Thank you, Ralph. That was a great talk.
Yeah, the use
Do we
cases
have
were awesome.
Q&As that aren't should we go through the
Yeah,
Q&A?
let's do it. So the first one was from Roy R. And he pointed out that right now it's an exciting technology. And the main issue he has is with language support. So well supported for
Right.
JavaScript and Rust, not so much for Golang, Java, Python, and other languages. Any thoughts on that? Is it one of those things
Yes.
that as
Okay,
more
these
people
are-
move over, right?
Yes, this is a great question. Let's be very, very clear. So almost all of the statically compiled languages have excellent support. So you're really thinking Rust, C, C++, and then some other liminal languages that are statically compiled. If you can go through LLVM, for example, you pretty much have support. There are a couple of differences. Go is mostly statically compiled, but not. There's a runtime, right, that does, GC and things like that. Because WebAssembly specification does not have memory management or GC or threading, you should think of it more like Node. It's like a Node environment was originally. It's super useful, and Node is everywhere, so you can't argue that it's not useful. But you need to realize that those kinds of, if it's an interpreted language, you're going to have to bring the runtime into the module. So Roy's absolutely right that the best support right now is for that. Now, the second part of that is the interpreted languages are getting very, very close. So JavaScript is reasonably well supported in the functions as a service, and just now becoming supported very well in backends like the Kubernetes one. So although we didn't show you JavaScript, I can show you JavaScript right now. I can also show you Python. I can also show you Ruby. I can also show you PHP. Now, all of these things do compile, but you have to actually believe that there's a need for this, right? Because these languages are going to bring their interpreters, their GC and their threading into the module. The module will get a little bit bigger. Let's take .NET as an example. .NET does run in this, okay? And in fact, .NET has debugging, like interactive debugging in Visual Studio Code. which most of the languages don't actually have yet. So like, it's not even the language support that's a problem right now. It's the fact that you can't debug this very easily already, unless a UI like Cloudflare or Fastly or something like that has the debugging built in, right? So you can't think of it as yet ready for mass adoption for everything you want to do. Even if you were convinced, like by my presentation, it's the coolest thing ever, you're not going to do it. Okay. So Roy's right about that. But by the end of the year, you will. You will have Python. Wow. You will be able to run an ML workload. I will post a video. In fact, I have a video of an ML workload which is 2.7 megs, which has a MobileNet V2 model in it for inferencing images. And we run it on Windows. We run it on Raspberry Pi, which is ARM, and on a Mac Intel, and with GPU and not GPU. It's the same module. It runs everywhere. That's the kind of portability scenario that you're interested in. It's not just pure speed or pure language. It's like, even though Python sucks in terms of speed in WebAssembly, because it has to bring its own interpreter and all that kind of stuff, if you need to run it on the space station, right, you can. You can do your ML there and not send the data back. And so those are the engineering trade-offs that you're going to be into. By the end of the year,
I was going to say, speaking of use cases, we got like 6 minutes till the top of the hour, so I want to get through these three questions. Suvro pointed out telco 5G is heavy on edge computing, I think was supposed to be said there. Could you please shed some light on how WebAssembly can help 5G telco deployments?
Pretty simple. It's a cloud-native binary, so 5G deployments are expensive. Those nodes are not cheap because there aren't that many. They will advertise that they run Kubernetes, but guess how many nodes you get? 1, if you're lucky, maybe 2, if you got a big wallet. 3, you probably own the part of the phone company. So in 5G, you're going to be able to run full clusters of WebAssembly and not containers. If you try and run container, that's going to burn through your wallet like you can't believe, right? But you saw the size differential between the container, right, that I was running and the WebAssembly. Those aren't exactly apples to oranges. I changed to a static language, okay? But I still would have gotten a 20 or 30 fold reduction in size. And because of that, 5G is a fantastic scenario. Space is a great scenario. 5G, automobiles, trucks, industrial automation, like all that other computing we can perceive is coming in, but is currently native and not cloud native, right, is a target.
Yeah, I think as you're seeing the control plane get separated from Kubernetes too, you have the use case where the control plane can be separate, and then it's just managing things like WASM on the edge nodes, right?
Well, and I think we're going to get disconnected. We're going to get disconnectable nodes, right?
Yeah. There's another question actually that leads into this. Does it look like there might be more native support in the future for running WASM modules in Kubernetes via kubelet?
Okay, so we did build Crustlet, right? Which is this, and crustlet.dev. Okay, and if you want to go and look at that, you can install it and run it. It works. So knock yourself out. We know people are running it. There's a Crustlet channel in the Kubernetes Slack, and we're there. But we stopped investing in it, most of us. It's still there. It's fine. It runs great, and it has a great Rust-based OCI distribution crate, for example. But we stopped investing in it because it has one unfortunate feature, and it makes the nodes special. So now you got a node that only runs WebAssembly. That's pretty unique. So the answer is yes, you can do that. Okay. But our objective was to make sure that you could run containers and WebAssembly and think of them just as pods and with the same YAML and that kind of thing. And that's what we did.
Awesome. And then I think we're on the last question right now. We got a couple minutes left. Are there other Containerd shim implementations planned for Azure WASI Preview, like WASM Edge, or even bring your own shim?
Yeah, so that's a great question. The answer is sort of yes, but like we're really working out like what it would be. So if you're interested in shims, and Sven is obviously, the Deis Lab Run WASI shim was forked by Second State in order to support using WASM Edge as a runtime for the Docker desktop preview that I mentioned in the thing. They submitted the PR back to us. So we're trying to unify the run WASI shim so that it supports multiple runtimes. So the first answer is there will be other containerd shim implementations where you can select out the runtime you wish, right? And then the question becomes more like an Azure WASI preview question versus an EKS question or a GKE question or what's your distro, right? The answer is we're supporters and investors of the Bytecode Alliance, and there are two engines there that we have confidence in using. I don't want to say confidence; it's the wrong word. Second State does great work, and WASM Edge is really, really cool. And there are about 10 good runtimes that are open that I would use if I were just a solitary developer. But for AKS customers, we want to have confidence in the community, the foundation, the whole dependency. And so we got to narrow our choices to WASM time. And the other one, which is optimized for small environments, very small, is the WASM micro runtime or WAMR. So you should see those two in Azure, in AKS, out of the box in the sense you'll touch a button and you'll get one of those two. And they're mostly optimized versus super edge small cases versus, hyperscale or CDN kind of cases. But the larger answer is it's just containerd. You can use Wasm, for example. We'll just install it in AKS. So if you want to run Wasm Edge in AKS, you can.
Awesome. Thanks for coming on. It's actually perfect hour. It was a great demo. Jason, do you have any last minute reminders? Anything you want to close out with before I head to lunch at least?
I think remember to fill out that survey. Like you said, there's a bit of Stack Truck gear on the line there, so please fill out the survey. It helps us. We'll give the feedback to Ralph as well.
Please do that.
We absolutely will. And again, just keep your eyes open for our future events. And this is our last event from this CNCF group, the Canadian Eastern Canada CNCF group. So we wish you best of holidays. Hope you have a relaxing, great time, and hope you have a wonderful New Year. So thanks again. Thank you, Ralph, for a wonderful talk, and we'll see you all later.
I'm coming up in February. I want to do the in-person. Let's do it.
Perfect. We'll see you there.
Okay. Bye, everybody.
Take care, everyone.
Take care, everyone.